Hey guys, welcome back to the shop. So we're continuing on our machine work for our USA made Fireball Tools Hardtail Vise. In today's video, we're going to be getting into some CNC lathe work. I've been continuing my training and practicing and hopefully learning some stuff on our Milltronics CNC Lathe. And this is a great opportunity, a great project to jump back in there, work with some Fusion 360, do some training there, and try to make a component part that's not only looks good, but it's functional and fits as well. The part we're going to be making is what I call the swivel bolt. This is the swivel bolt that was shipped with the vise here. Now, this most likely is one that is made over in Taiwan and used on the Taiwan-made hardtail vise here. Whenever Jason sent me these parts, his USA hardtail, as of right now, is still getting into the production stages, so he's still working on having his parts machined so that he can start selling the USA made version. As of right now in December, it's still not there yet. So this maybe is not a part that they started machining. I really don't know the specifics about this, but what I will tell you about the swivel bolt, it's a relatively very simple lathe part to make. So this is a very good project to practice with Fusion or whatever CAD software that someone might be using. I use Fusion 360. This, I believe, is a cast iron part. I think they cast this, and I don't know if they turn it, but this is definitely like a belt sanded OD right there. The threads have a little bit of a looser fit than I like, and you know, it's just not very attractive. Now, I will say, the funny thing about this part right here is that once it's installed on this vise, you're never going to see that again. The only time you'll ever see this is if you take the vise apart or you pick it up and you look underneath it, okay? So just so you guys are kind of aware, that's going to fit in this part right there. This is your base, but it allows you to swivel the vise, okay? Just like that. Keeps it on center, keeps it in the middle. It's just like a shoulder bolt. So this is going to screw in, it's going to rest on this face there, and then the swivel base right here is just going to be able to spin on that journal there whenever you want to move the vise around to whatever position. All right, so I've been working with Kevin over at Mechanical Advantage. I've been training with him just about every week for an hour or two, maybe a little bit more than that. Whenever we have time, we jump on there, and he's been helping me out, and he's become my teacher with Fusion 360, and I really appreciate that. So it's been great working with him. So he has helped me with this program right here. I've been using some of this old scrap drop material, just some cheap old 1018 cold rolled, I'm sure is what this is. This was originally a shaft that I had to mill some keyways on over in the Flex, and I kept the old shaft, and it's perfect for stuff like this. Just material that's free. It's not worth anything really, except for being able to cut it up and make other parts out of it or use it for scrap material to test parts on. And that's what I've been doing. So I've got a few of them machined right here. These are my test and tune pieces, I like to call them, because I write the program and we go out to the machine. I make a cut. The thread pitch is a great example. I measure the thread pitch. It's not right. I got to make some adjustments. So I just continue taking these little short pieces, and I'll turn one, flip it around, turn the other one, cut it off. All right, so we've got some sample pieces that we can use to prove our program out and get it exactly the way I want before I take our good 4140 material, which is what I'm going to use for my piece. I want to make sure the program is proven out before we actually cut this right there. I do have some more of this just in case that, you know, I screw it up again. This is one of the latest ones that I turned right there. You can see what I'm talking about. And I finally got my thread pitch landed on not only the size I wanted, it actually looks good too. So this is something that I have been struggling with on this particular job. I know it's kind of hard to see this, but I was just getting some chatter in the machine. And that's another reason why I wanted to go ahead and swap out the 6-jaw chuck and put the original 3-jaw on there to see if it made a difference. And I think that it did make a difference. I don't know what's up, if the chuck is just too much mass for that lathe, or if you got too much hangout from the spindle or what. But we put the other 3-jaw on, it's been working really well. All right. So I'm gonna get you in here a little closer and show you how this stuff fits together. I wanna take you in there to the computer and I'll just give a quick rundown of the program that we wrote in Fusion to make this. And then I'd like to get over on the Milltronics and see if we can get one of these successfully machined for our hardtail vise. So one of the things I wanted to do as well was make a nice fit inside this bore. So we have a video of facing and boring this over on the American Pacemaker. If you haven't seen that, check that out. But you can see what kind of loose tolerance they've got on theirs, okay? Lot of clearance in there. My goal was to make everything fit a little bit better. So this is one of our samples with a bad thread, and it's got a good fit. So I've given this 2/1000 clearance. So whenever you loosen the vise up and swing it around, you're not going to be seeing it shift back and forth on the swivel bolt there. And this is how it's going to go together once we have our bolt finished up. These two faces mount together like so. And then we have our, we'll just go ahead and use the original and show you what I'm talking about. So that's going to screw in like so. Now we don't have this finished yet, so it's actually tightening up, but the way this is made is like a shoulder bolt. This should tighten up, but after this being tight, this should still move, okay? So we've got a little bit of finishing to do on this counter bore inside the base right there. But essentially that's what we're gonna do. I'm not gonna make mine with a slot to tighten it up. We're actually gonna use the mill, and we'll machine a hex in there. That's my plan anyway. So it's another good reason to have these sample parts that are basically failures, but they allow you to prove the program out. So we'll be able to go to the mill, drop these in a chuck or something like that, and come in here and finish out the back side. So you can see the way I'm doing it. I'm turning it, do all the lathe work. I'm not parting it off. I'm just simply taking it out of the chuck, bandsawing it off, and then we'll go to the mill and we'll just mill it and chamfer it and machine the hex in there. Again, we're gonna go, we'll probably set this up in our Milltronics. I'd like to come in there and face this out. We need to take a little bit out of that. It's really not a lot. There's not gonna be any more than 40 or 50 thousandths come out of this face. So we still gotta do that. And then the other thing I'd like to do, this is gonna be on another video by the way, but I wanna just go over it since we had this in our discussion here. The ears, the 4 mounting ears where this gets bolt down to the table there, the factory doesn't machine this. There's really no need to, but since this is a project we're working on, we're having fun, and we want to make everything as precision as we can. We're going to come in here with a face mill and actually machine these 4 faces so that they're all nice and flat. They look good, and it looks like a finished machine part. So that's something that we'll set up and do in another video. Get those 4 cut, and then finish this counter bore in here as well. I got you in here at the computer to show you I just wanted to kind of go over this little program quickly, and we can even give you a simulation so we can see what it's going to be doing on the machine. I'll rotate this guy around a little bit. Just bear with me. I'm still learning the controls of Fusion 360 and not completely familiar with everything, but we'll see if we can give you guys a little spin here to see. There's the top side, so that's going to be the milling that we're going to be doing. But for now, we're going to be focused on the lathe work, okay? We'll go ahead and bring it back to our home position. So what I'll do is click on lathe. So that's going to be our stock that you see. We'll hit simulate with machine, and we'll go ahead and run through our machining. So we're going to come in and face it. This is going to be a rough turn here, DNMG insert, and we'll go ahead and rough turn the OD. And then once it's done roughing, it's going to grab a finishing tool, which is going to be a multi-directional tool that I'm using. Make 1 pass to finish it. We've got a grooving tool that's going to come in there, do a nice radius thread relief, and of course we're going to do our thread there. I haven't figured out why it's making the tool turn red right here. Obviously it sees something that I can't see, but I've already proven this program. The tool is not going to crash into the shoulder, and it's not going to be cutting into this bottom diameter, this radius diameter here. I think it has something to do with, let's see if I can get this turned around. I think it has something to do with this little radius area right there that it's kind of coming into. But we'll go ahead and finish out that simulation. I'd like to show you something interesting. Let's go to top and let's play this again. What I want to do is kind of get to the, let's see if I can speed this up. Finish, and then we want to come in. There's our radius tool right there. Let's see if I can do it. Yeah, there we go. I like this tool path that this is going to do for us, and Kevin helped me out with this because there's all kind of options on how you can come in and use a tool, right? And I really like the way this is going to come in. Instead of just plunging in, that causes chatter, so it's actually going to be coming in and taking small cuts there. It's going to come in on either side and clean it up, just like that right there, and boom, it's done. And this happens in a matter of just a few seconds, and that is done right there. And that retracts, our thread tool comes in. This is something that I played with quite a bit, is the thread, because I just couldn't get a good looking thread. But I think part of the problem is that this is, the material that I've been using is, I think it's 1018, so it's very soft and gummy. So it's leaving a really bad looking finish across there. But I was playing around with the number of passes, the type of infeed that it's going to be doing, and I think I landed on a good formulation here. So I've got this set to 7 passes total plus a spring pass. So it'll actually be passing through there 8 times, and it's landing exactly on the pitch diameter that I want. This is a 5/8 thread, by the way. And it's that last one I did, it turned out beautiful. It's got a good pitch there. So I think we got a good part on our hand. So we'll go ahead and we'll go out there to the Milltronics and we'll get a sample piece set up. I want to show you the sample just like this right here. And once we do that, we'll switch over to our 4140 material. And I'm going to have to modify our program because my 4140 is a larger diameter, so I need to change our stock diameter in here. And then we should be able to cut a good piece there on the lathe. That's the hopes anyway. So let's go to our Milltronics and do some machining now. All right, we're going to be running our Milltronics USA ML16 to CNC lathe. We've already got her warmed up. It is ready to go. I got this shorter piece here that I think we can still run. It's going to be most engagement of the jaw right here. So what I use, I got this little depth gauge here that I've got it set about 3 1/64 inches, and that'll give us about a 15th thou face cut. We just bring it up flush to the jaw like that. I've got our Z dimension touching off right here on our material. Okay. All right, let's get going here. So again, this is just another practice run. This is just another simulation of what I've been going through, doing my testing and tuning and adjusting. And I think we got everything where we need it now. All right, got the lathe closed up. Let me go get our file started. Make one finishing pass here across all the diameters and the chamfer. Clean the face up there as well. Now we're going to switch over to our grooving tool. This is that grooving op that I think is really cool. That's how fast this happens. Done. What was that, 3 seconds? And then our threading pass. That was a spring pass. Looks like I need to make an adjustment on that coolant nozzle again. But there we have it. Oh, we got some coolant on the camera, so it looks like we've got a blurry video, but anyway, there's another sample run on our cold rolled material to get the program proven out. Here's another look at what we just did, turning our sample piece. Just get another video because the coolant splashed up on the camera last. So let's just run this one more time. What I like to do right here at the end, it's got just a tiny bit of burr on the top of that thread. I just turn it on and just a mill smooth file, a couple of licks. There we go. It's really cutting that thread beautifully now. Here's a little bit better look at those threads that we just cut and the sample there. Not the best threads out there, but there's certainly a big improvement over what I've already cut. They look good. So there's another successful sample piece right there. I think we're ready to move on to our 4140 to hopefully make our final part. Okay, so here's our sample that we just machined. Let's check our fit. Got a good fit. Very little movement in that. I've got this machine to a tighter tolerance. I believe it's a class 4 fit. If you was to use just a standard hardware grade bolt in there, you would have more movement in that. But I was just trying to make things a little bit more precise, a little bit tighter. Things made to a little more precision. So they're definitely improved over my first test runs on the appearance of the thread, but they don't look bad at all. When I'm looking at that side of the thread, it looks really pretty. That side's got a little bit more uglyish look to it, but it's not bad at all. I mean, there's nothing wrong with that thread. It's definitely better than some of these other ones that I've done. That one's got a lot of chatter in it. But anyway, I think our program is good to go ahead and run this. I just wanted to show you kind of what I've been going through on my learning process. And it takes a little while to get this kind of stuff done. I know the guys that are proficient at this CNC stuff can do this a lot faster than I can. I'm not out here trying to be the, the fastest CNC guy in the world, because this is all new to me. I'm learning how to do this stuff. But this, just for example, I could definitely take this stock right there and go to the manual lathe, turn this, undercut it, thread it, and be done with that in a very short amount of time. When I compare that to how much time I've got in all of this, learning how to draw this, and then going to the machine, getting the tool set up, and then practicing a few times, making a mistake, the thread isn't right, something isn't right, the journal's wrong. I've got a lot of time in this right here. But now, since we've got a good program, we can machine these things very quickly and make a small batch of these in a matter of an hour, really, or less. So anyway, that's just my random thoughts as we sit here and look at this hardtail vise. So I think what we're ready to do is I need to go back into Fusion, modify my stock size from this 2" up to this 4140 that we're going to use. I think it's 2 1/4. Let me get my hook scale out and we'll see. Yep, so 2 1/4. So we'll have to modify our stock diameter in our program so that we start cutting on this 2 1/4 diameter. And let's see if we can get us one machined that hopefully is going to look a lot better than that soft metal there out of this 4140. Okay, we are ready to load our 4140 material. Now I had to do a slight modification. I did this over in the manual lathe, took a couple minutes to turn this down because this has it's about 2 1/8 spindle bore here in the chuck, and then the spindle bore of the machine is 2". So I had to take that down a little bit further there just so that this piece could fit. But what I do is plan on machining 2 of these out of the stock. We're going to machine one end, and then what we'll do is flip it around and go ahead and turn this side there as well, make 2 of them. Just get it chucked very closely, and then use our depth gauge. Space it out. I get it to where it's just off that jaw. It's just going to be a few extra thou to face off. And that gives it approximately 15-20 thousandths if you measure that out right. It cleans that face up. All right. Go ahead and tighten all 3 of those. I haven't cut this program in 4140 yet, so I don't know how this is going to do. I'm hoping that we don't have any kind of pushback. That's why I went ahead and snugged all 3 of the pinions there on the chuck. So nothing left but to let it rip and see what we can come out with. Let's get going on our first finished swivel bolt. I think everything worked out good with the exception of a little bit of chatter in that threading op. And what I had done is I dropped it down to 90% on the spindle speed. Those last couple passes, it seemed to help it. So I may need to adjust that speed once we get to our threading op on the next try there. I'm going to do some measuring, see where we're at, see if we still landed on the same sizes as before. Just do a very light thread file there to knock off any burrs or fuzz on the thread. Hit that first thread to kind of get it deburred. Check our journal diameter here. Nice. 1.374 and 7/10. So my target is 1.375, but that's right in line of what it was turning on the junky material. Let me get I'm going to get my thread triangles here. Measure this thread pitch diameter and see where it's at. All right, 83, so that's 0.883 and 2/10. That's right in line with a class 3. It should be a class 3 with my thread triangles. So we hit our size where we want it right there. The threads don't look bad at all. We had a little bit of noise coming from it, but I think slowing it down right there at the end helped it. On the next one, I'll probably drop it down, let's say 80%, and see if it helps it anymore. So I'm happy with that. All right, let's flip this guy around. Let's see if we can get another one machined. Ugh. So what I'm gonna have to do, I'm gonna go back over to the manual lathe and just turn that little step off right there. And then once we do, that'll flip, technically I could do it right here on the CNC, but I just feel more comfortable walking right over to the manual lathe, turning that, be done it, coming right back and not having to change anything here. Okay, we got that little area turned. Let's do a repeat, hopefully. Okay, our second one was not as successful as our first one. I had pushback problems again. You might have already seen it, but see, we got those steps in the face. Every time we get into that finish cycle and I see the tool coming up on the face, whenever I see those little steps in there, it tells me that we have pushback in the chuck, and that's exactly what happened here. Is it pushed every pass, it slightly was pushing it back in the jaws. So that's a problem that I continue to have right there. And I really wasn't having a lot of issue with that. That's the first time I've had that. So apparently I did not tighten it enough. So I need to get some more torque on this 3-jaw whenever I tighten it down for stuff like this. Now I'll still be able to save this and use it. I don't necessarily need to scrap that. What I'll do is I'll set it up in the manual lathe and just touch these faces up right there. Honestly, that's all we need to do. So, but this is one that I'll just, I'll keep on my shelf there as a keepsake or whatever. But I do plan on cutting this off, and I want to make one more out of this piece of 4140 right here. All right, so we've got a Walter threading tool with a radius insert in there. This is the same size as what we use as a CNC lathe. We've already got it touched off on that face, and this shoulder length is 0.875. I've already got that set. Let's see how far off it is. I'm gonna come up here and just touch it. All right, we're still at 14 thousandths, so I don't know. So I guess maybe about 14 thousandths or so every pass. Let me go ahead and clean this up. can touch the bottom of that radius that we cut in there. Bring it to our 0. Blends in nicely. Next shoulder there, that's going to be 1 7/8 to this shoulder here. Yeah, that was showing 11 thousandths off. I've already got an X0. All right, we got her. Just not pretty like it was. Get a chamfering tool. Make a couple of chamfers here. All right, there we go. Still usable, just not as pretty with those other finishes there, but we got a good part. We're over in the hide mech. Let's get these guys cut off. That's one of the things I love about my saw is the way hide mech builds these vices right there. They stay parallel so you can clamp a relatively short piece of material in there and be able to easily cut it off. So I've got a square butt here that we're going to use. Just put it on the end like that. Looks like about where it needs to be. So we're cutting it a little bit long so that we can finish that face in the milling machine there. I'm just double checking. I want to make sure that I got it set right. I wanted 2 1/16. I got just a skosh past that line. And we're just touching that blade. Should be good to go right here. Put it in semi-auto. Looks like I'm low on coolant again. We'll need to get that topped off. We don't want to cut that 4140 dry. All right, we poured a 5-gallon bucket of coolant in the sump here, so hopefully that'll fix that problem. Let's see if we can get our last one cut. I think this one turned out pretty good. We didn't have that pushback problem there. And using up that last bit of 4140 stock that we started with. Okay guys, so our CNC lathe work is now completed and we have 3 successful parts here that we can use. Now this is the one that we had pushed back, but it's still gonna make a good part. I just had to get interface that off as you saw. But these guys turned out good. So I parted this one off in the manual lathe because I haven't done any deep parting like this on the CNC lathe yet. And I'm real nervous about trying that. I don't have any kind of way to catch the part. I didn't want it to fall off and fall down in the machine. So doing it manually like that is the way I'm used to doing it. Just made more sense. I had my little glove on so that I wouldn't cut my finger on the thread right there while it was spinning. All right, so we got that done. And they look good, okay? These are all of our practice parts using the gummy 1018 material, and I definitely like the shine that is coming out of the 4140 finish right there. So lathe work complete. We'll go ahead and give it a little test fit here so you can see they do screw in. It's got a good fit there on the thread. I ended up making this a class 3 fit according to my thread triangle chart. It should be a class 3 fit, so it doesn't bind up or anything and it's not too loose. It's just got a good fit inside there. And then inside of our swivel plate, we'll go ahead and check that too. There you go. We got 2 thousandths clearance inside that swivel plate. And then once we actually finish this guy, we need to come in here, like I said, and mill this out because it's a little bit too high right now. We get that milled. Once this is installed on there and this bolt is tightened up, you should have just a little bit of clearance between this shoulder right there and this face right there, so that whenever you loosen the vise up, the plate will swivel there and you can position the vise where you want it, okay? So I think that is it. We are now ready to go over to our Milltronics CNC mill and see if we can finish this guy out. So the way that the program should work for this, I'm going to set up an indexing spacer with a 3-jaw chuck so that we can drop it into the chuck like that, and we're going to use a face mill to come in there and face that off. We'll come in and drill a series of 6 holes, and I use a 1/4 inch end mill to come in there and mill that out to the hex, and then a chamfering tool to chamfer all the edges. And then for good measure, we're going to engrave the A-Bomb79 logo on that face there as well. All right, so hopefully all that'll go pretty well. I'm excited to get to it. That's going to be the next stage. I'm going to start on that right now. But I hope you have enjoyed this project and this point of where I've gotten this right here for our swivel plate. This is another learning session for me, learning and training how to use Fusion 360 CAD and CAM, practicing on the lathe to be able to make parts like this more efficiently and do a better job at it, okay? So I hope you guys have enjoyed, and I hope to see you again on the next video where we complete these guys out.